first thing we need to do is get some vocabulary out of the way. Now, some of this we might be aware of. For instance, a number x is a square root of a number y if x squared equals y. Now, we understand what this means intuitively because we know that if I have 2 squared equals 4, 2 is the square root of 4. If I have 3 squared equals 9, 3 is the square root of 9 because 3 squared equals 9. Now, the expression, the square root of x, is usually referred to as a radical. Most of the time, we do just say the square root of x. But it's important to realize that this whole thing, whatever x happens to be, this is referred to as a radical. And the square root symbol, what we usually refer to as the square root symbol, is actually called the radical sign. The number beneath the radical sign is called the radicand. So if I had the square root of 3, the entire thing would be the radical. The symbol is the square root, and the number under the square root or radical sign is the radicand. So that's some basic vocabulary. Now, the idea behind simplifying radicals is splitting up whatever numbers we have as the radicand into perfect squares, right? Because whenever I have a square root, I can always remove perfect squares. I can't remove things that aren't perfect squares from underneath radicals, but I can remove perfect squares. So, to do this, we're going to use a couple of different properties. The first is called the product property. Now, the product property, you might be aware of, refers to multiplication because product means multiplication. Now, what the product property says is that if I have the square root of some product, a times b, I can take that square root, that radical, and I can split it up so that it will no longer be one radical, it will be 2 radicals. It will be the square root of a times the square root of b. Right, so we've taken this product ab under the radical sign, and we've split it into 2 separate radicals being multiplied together. The square root of a times the square root of b. And we have a little example off to the side here. As you can see, I have the square root of 18, and like I said, I want to simplify the radical by splitting it into perfect squares. So I looked at 18 and I said, okay, well 18 is 9 times 2. 9 is a perfect square. So I split the radical into the square root of 9 times the square root of 2, and I could remove the radical from square root of 9 because the square root of 9 is 3. So the square root of 9 just becomes 3. The square root of 2 isn't a perfect square, so I can't remove it, and it stays the square root of 2. So the square root of 18 splits apart into the square root of 9 times the square root of 2. The square root of 9 becomes 3, and square root of 2 stays the square root of 2. Now the quotient property deals with division because quotient is the result of division. It says that if I have a square root, a radical sign here, and the radicand is a fraction, a over b, I can pull that fraction apart, and instead of having the square root of a over b, I can have the square root of a over the square root of b. So I can pull apart a fraction the same way I could pull apart a product. And let's look at an example here. I have the square root of 2 over 25. So the quotient property says I can pull that apart into the square root of 2 over the square root of 25. Now, of course, the square root of 2, just like we saw, we can't break that down any further. There are no perfect squares in there. But the square root of 25 is a perfect square. And the square root of 25 is 5. And so we can simplify square root of 25 into 5, making our final answer the square root of 2 over 5.